Welcome. I think you're familiar to me. We're going to talk a little about AV over fiber, and this is something that's particularly important in the AV industry as applications converge over an IP network. So, just to introduce myself, I'm Tony Veatch. I'm the Director of Product Management for the Siemon Company. And Siemon Company, a little background on us. We were founded in 1903. We're headquartered in Watertown, Connecticut. And we're a manufacturer of best-in-class IP solutions, typically copper and fiber cabling systems. And we're going to talk a little about how fiber optics can help AV installations in certain applications. So why fiber for AV? The short answer for why is distance. The bandwidth of fiber is much greater than copper, so there are certain applications where fiber can make sense. Situations like campuses, stadiums, hospitality, just places where you need longer distance than copper can reach. Some of the other things that you could do with fiber that you can't do with copper, noise immunity. So fiber is inherently more noise immune than copper because there are no conductors. So in situations like government, security, maybe healthcare, there are benefits to fiber for eavesdropping and for sniffing sorts of concerns. The smaller diameter for fiber optic cables can also be beneficial. If your pathway spaces are limited, you could get more fiber in the same amount of space than copper. The other thing to consider with fiber from a bandwidth point of view is that it is more future-proof than copper. You know, nobody could say exactly what is going to come in future generations of AV systems, but the bandwidth of fiber being so much more than copper when you think about HDMI 2.1 or some other future applications, fiber certainly has the potential for more down the road. So, how is fiber typically used in AV? In a backbone switching situation, it's certainly used, and this is something that AV integrators may or may not experience because it's common with a LAN switching environment in a backbone or switch-to-switch connection. Where AV integrators, though, may be involved is in cases where you might previously have had copper cabling that you want to switch to fiber for the reasons that I mentioned before. So it could be cases that are point-to-point, it could be daisy-chained, it could be a star network topology. This is where you may see fiber in AV installations. One reminder on these applications is duplex versus simplex connection methods. So in a duplex, you have a transmit and a receive. So if you have something coming back on the AV system, it's going to be a duplex application. If it's just a one-way transmission, it's going to be a simplex application. A little bit of a reminder for you on what are the various fiber types that are out in the market. There are basically two different fiber types, single mode and multi-mode. Single mode is known as OS1 or OS2. It has a smaller core. It's only transmitting a single mode of light. And what's notable about single mode is distance. You can get, depending on your application, up to 10 kilometers over single mode. The cost of the cable itself tends to be lower than multi-mode, but the cost of the equipment tends to be a little bit higher, although that is shrinking over time. Multi-mode is much more common in building applications, typically 300 to 500 meters. And it transmits multiple modes of light over a larger core. And in reverse to single mode, the cabling cost tends to be a little higher, but the active electronics cost tends to be a little lower. So if you do choose to use fiber in an AV application, you have a choice then of what termination methods do you use. And there are really four main termination types that you can choose from. And we're going to talk a little about the pros and cons of each one of these. But in short, pre-terminated assemblies are factory terminated. They're out of the box, plug and play, ready to go. Fusion splicing, and in the show you'll see a number of manufacturers who offer fusion splicers. These are machines that will fuse two fibers together in the field. Epoxy polished connectors are basically a glued-on connector. more of your older style of termination. And then mechanical splice connections, which we're actually demoing right here on the table with our Lightbow product, is a very fast, relatively low-cost termination method that even an inexperienced installer can do. So to talk about these 4 options a little more and what are the pros and cons of the termination methods, pre-terminated solutions are great because it's done in a controlled environment in a factory. You unpack the box, it's clean, it's ready to connect, so field installation labor is very low. There's no termination skill set used because it's done in a factory, and there's low risk of contamination. So for fiber optics, that's something that is very sensitive. You have to clean your end faces if you're doing termination, so having that done in the factory can be a really big benefit. On the con side of pre-termination, the big thing is you need to know your length. So if you order an assembly that's too long or too short, you either have to deal with not having the right length or with managing the slack in that installation. Polarity might need to be dealt with, and in some cases material cost can be higher, but that really depends on what your field labor costs are to do a field termination. Fusion splicing is obviously a very common method out in the field. Some of the pros, it is your lowest loss connection option because the machine is controlling the fusing of the fibers. It is green, there's less packaging, there's less waste. The material cost can be quite low, and it's a very predictable, very durable method of terminating fiber. On the other hand, some of the cons are that you need a relatively expensive fusion splice machine to be able to do this. And that machine takes batteries, you need to manage the power, you need to make sure that you don't damage it in the field, so it is a little sensitive in that regard. Like many termination methods out in the field, the performance of the termination depends on the quality of the cleave on the fiber, so that could vary. And you need workspace, you need mobility, and the connector cost can be a little on the higher side, but this is one of the more popular termination methods out in the field. Epoxy polish connectors, on the other hand, are really a less popular method because alternatives have emerged that are just less costly and more installer friendly. It is the lowest connector cost option out there. From a con point of view, you're gluing connectors in the field, so it takes a skill set, it takes various tools and consumables to do this installation, and it takes time to do it. So this is a method that is quickly diminishing as far as popularity is concerned. And lastly, mechanical splice connections. So these are pre-polished connectors that are relying on an index matching gel and a crimp to make your connections. Some of the benefits, it is the fastest termination option. You'll see demos here in a minute or less, no pressure. And limited waste and scrap. It is a very low-cost tool typically, so it's not a powered tool. You don't need batteries generally. And a very low level of skill is required. So if you could terminate a copper connection, you could terminate a mechanical splice fiber connection generally. Some of the cons, it does have slightly higher loss than a fusion splice, if that is important to you. Again, the performance is dependent on the cleave, and these solutions are manufacturer specific. So one manufacturer's mechanical splice connector cannot be used in another manufacturer's tool, for example. So in summary, when you compare the pros and cons of all these different methods, it really depends on what you're looking for. Performance, ease of use, the cost of the connector. In an AV installation, you can weigh based on things like your workforce, how commonly you're doing fiber terminations and not, how cost sensitive are your jobs, what's the reliability like. You can weigh each of these options, and generally I'd say the two most popular that people settle on are fusion splicing and mechanical splice. So switching gears a little bit to fiber fears and misconceptions. So fiber has changed in the last 5 years, 10 years, 20 years. Many people see fiber as, a brittle glass, and that's not the way it is anymore. Fiber is protected, it's cabled up. Bend-insensitive fibers allow you to wrap it around your finger and have an acceptable bend radius. So it really is a very durable transmission media for indoor and outdoor applications. Another fear is that fiber is too expensive. And maybe that was the case years ago, but fiber costs have gone down and down. And some of the reasons for that are that many data centers like hyperscale have moved almost entirely to fiber. Many fiber to the home, outside plant, telco transmission networks are using massive amounts, massive volumes of fiber. So all this just contributes to the economies of scale to bring the costs of fiber down. Some feel that fiber requires specialized expertise, and you'll see a termination method here that is under a minute that can be done as easily as a copper connection. So this simply isn't the case with modern fiber connectors and termination methods. And finally, you can't send power over fiber. Well, technically that's true, right? You can't send power over a fiber optic piece of glass. But there are hybrid cables that have a power conductor and a fiber cable all under one jacket. So if you have, say, a remote camera that requires powering, you can use that power conductor for that and then bring back the signal over the fiber optic cable. So a nice option for that application. So again, who is Siemon? We manufacture structured cabling systems, among other products that are used in IT networks. We do have a very full range of fiber optic products that are used in AV data centers, enterprise LAN applications, everything from pre-terminated to field-terminated splice options. And in particular, the product that we're highlighting here at the table is the LightBow mechanical splice termination. So again, it's under a minute. Anybody can do it. And this is...
LightBow Fiber Termination System offers the easiest, fastest, and most reliable termination with its simple yet cost-effective tool and pre-polished multi-mode and single-mode mechanical splice connectors. With no batteries required, the ergonomic LightBow termination tool combines both splice activation and mechanical crimping with universal LC and SC compatibility. The tool features alignment channels to simplify fiber insertion, and the connector dust cap stays in place to protect the end face from contamination. By creating a simple bow in the fiber, proper pressure is maintained throughout the termination process to eliminate air gaps. The connectors feature a built-in VFL window to easily verify a good termination, and the connectors can be re-terminated if necessary. Try Siemens LightBow Fiber Termination System today.
If you'd like a demo, Carol has a demo over here, and she can walk you through the termination, and you could see how quick and easy it is. So thank you very much for your time. We're a new member of SDVoE and happy to be here, and thank you very much.